We are in the final section of Chapter 4, 4.6, Grounds and Other Reference Points. In most circuits, there is one common point to which all circuit values are measured. Typically, this point is called the circuit ground. Usually, it looks kind of like that. In all cases, ground is considered to be 0 volts and is typically one side of the circuit's power source. The two circuits below are electrically the same. The schematic to the left shows a complete loop for current flow, and so here you see the complete loop, which is an expectation for all electronic circuits. You must have a complete loop to support current flow. The circuit to the right has eliminated the lower wire and replaced it with an additional ground. And so notice here that the wire across the bottom has been eliminated, and they've just placed another ground here. For electrical purposes, though there may be multiple grounds, they all represent the same point. This simplifies schematic drawing. So you will commonly see in schematic drawings that rather than run this wire all the way across the page to a common single ground point, they will just show multiple grounds, but it's understood that they all represent the same point. Circuit boards will normally contain a ground plane to which all ground connections are made. Circuit boards usually have several layers. At least one layer is frequently made of solid copper and is dedicated to providing ground connections for all other layers. And so here we see a ground plane for a circuit board. Non-ground references. In some cases, a voltage is measured that is referenced to a point other than ground. So usually if you're measuring from, if you're measuring point A, the reference point would be ground. And so what do we got here? We've got, 10, 15, 21 volts. If we measured from point A to ground, we would measure 21 volts. But sometimes you want to measure, a voltage that reference to a point other than ground. So sometimes you might see something like this, VAB. And so in this case, you would be looking, for example, the voltage between point A and point B. And in this case, you would measure 5 volts. You commonly see it like this, where A is the measured point and then B represents the referenced point. So AB would be, in this case, 5 volts. The voltage potential for non-ground references is the algebraic sum of the 2 points. So if you measure from A to B, it would be 5. From A to C, it would be 9, and so forth. Voltage measurement with respect to ground. Okay, now here we have a circuit that's drawn a little bit differently than you might expect. Usually we would expect to see the ground at the bottom of the power supply, but in this case the ground has been placed at another point in the circuit. Now for electrical purposes, for purposes of voltage drops, and for purposes of current, there will be no change in this circuit because we still have a series circuit, we still have all our components, we still have our power supply, we still have ground. It's just the ground was placed at a different point. Now, what this will impact is if we're measuring our voltages with respect to ground, we will see some different values. Now here we have 20 volts applied, and if I measured from point A to ground, I'm not going to measure 20 volts. I'm going to measure about 13 volts from here to our point of ground. If I measure from C to ground, I'm going to measure 6 volts. So if we're in reference to ground, then we're going to see different values than we'd expect if the ground was placed over here. And we will certainly see some things different if we measured, for example, point D to ground. So in this case, we're actually going to measure a -2 volts if we have our voltmeter connected. So the common probe goes to the ground and the voltage probe goes to D. We would see -2 here. In this case, we measured here, we would see -7 volts. Now when you begin using electronics workbench, you'll be able to build a circuit like this, and you'll be able to measure those quantities and prove that that is in fact the case. Okay, this is our final section in Chapter 4, and we've been talking about grounds and non-ground reference points, and we looked at a ground plane on a circuit board, and we looked at the fact that typically on circuit schematics that return line to the single ground point is usually eliminated, and you might see many ground points on a schematic, but that they are all electrically the same point. And that concludes our discussion on grounds.